Good afternoon, ladies and gentlemen. Welcome. Thank you for your attendance at Qt World Summit. I'm Marty Udishas from the Qt company. I'll be your host this afternoon. And today we're going to be hearing from Simon Hausmann about the future of the QML engine. And this can be very interactive, so feel free during the presentation to raise your hand and I'll bring you the mic. So let's make it as interactive as you can. And with that, Simon, take it away.
Yeah, thanks for coming to this quick slot. So our goal is really to make him run around. So if you have questions, please ask, and he'll come and if he has sweat at the end of the time on his forehead, that means this was good. No, I normally have a longer presentation, but since I have a 25-minute slot, I'll do this very briefly, and I'd like to focus on things we have done in the past few months that you can benefit from with the next Qt release, and I'll look a little bit look a bit beyond that as well, what we would like to do in the future, and then that is also an opportunity to give me feedback and say, yeah, this sounds good, or no, please, this is not good, please do this instead. So what we focused on in the past few months and what should be available in your hands hopefully soon, definitely this year, are changes we've done in the QML engine to make QML run faster. The first bulk of the changes is about optimizing bindings. The time it takes the focus on this work was on reducing the time it takes from emitting a signal that something changed to the binding reacting to it and calculating a new value and then writing it back. And we found out that we spend a lot of time in meta calls and in converting types and packing types into containers that we can pass information around. And so we cut down as much as we could, and we had a reference benchmark where we just wrote in C++ what you would write in QML, and we were able to, on the way, reduce quite a bit of memory consumption, and we made it about 20% faster, to the point where in our benchmark, the C++ handwritten binding is just as fast as the QML binding. The QML binding is as fast as the handwritten C++. And one result of that was also that we gained time accessing QObjects. So every time you access a QObject property or call a function or so, that'll also go much faster, actually, a little bit quicker. So those are two very engine-specific things we've done, and things should just be better. If with Qt 5.8 something works slower, tell us. And the bulk of my personal time, that's why I'm standing here, was spent on implementing a caching mechanism, and that's the thing I want to go through in the next couple of slides. And this is also an opportunity to give feedback and say, would this work in your use case, in your scenario where you're using QML, or would it not? And then what can we do to make that work? But this is the thing that Lars mentioned in the keynote earlier, to make things faster. So let's look at that. Loading QML files, which is the first thing your QML or Quick-based application does on startup. It loads QML files. The first thing you tell it is load your main file, and that will subsequently load more files. And the first thing we end up doing is we open the file, we read it, we start to parse the source code, we look at what's inside, we analyze it. And the purpose of doing all of this is that we can instantiate objects. So take, for example, your button.qml. I'm sure all of you have written a button in some shape or form. You want to instantiate that button, and you will end up instantiating it many times. So after we've analyzed the source code, we try to create a data structure that allows us to instantiate your button many, many times. And we will also, since your button usually has logic in it that reacts to it when clicking, etc., you execute bindings or execute little code, we also end up allocating memory for code, and then we spend time generating native code from little JavaScript snippets that you have. And maybe you import some JavaScript library. We may also have to go off and compile that one. So that's in a nutshell the kind of work that needs to be done every time your application starts, and needs to be done for every single QML file that you load. So if on startup you end up loading 100 files, this whole procedure there needs to be done 100 times, which I'm sure you've observed because it's not very fast, and then you may end up using tricks like loaders to load things lazily. That can help, but it still doesn't get you around the fact that at the beginning you have to do this work, at least for your entry point. So the main issue with loading QML files, a lot of them, is that it takes time. It takes up memory. And even if you organize your larger scale application to share QML files, that you encapsulate graphical components into a shared module that you share between applications, the memory that we need to allocate, like I said, those data structures, that memory is not shared between the applications. So if your button is used by 2 processes, by 2 applications, we'll allocate memory twice for that button. And if for some reason you're in a very constrained environment and memory is running low, well, there's not much the kernel can do with regards to that piece of memory. In order to free up memory, like suppose you have 2 applications, one of them is a foreground, one of them is a background, and the one in the background really is not important, and you're really running low on memory because you need to play that video or something like that. The kernel could decide, okay, that application in the background, it really hasn't done anything. It needs to free up some more memory. The best thing it could do is could try to swap it out, but you may not have swap space even configured, perhaps. It's usually a bit of a tricky thing to do. Can ruin your flash. And the most important problem of all of this is that every time you start your process, your application, you do the same work again, again, and again. And this is, honestly, it's a bit embarrassing that this happens. It's kind of stupid. So to finally accommodate this, we developed a caching architecture to do this work only once, and don't do it again and again and again. So those data structures that I talked about, and the code that we generate, we do that once, and we write it to disk, and then we throw away onto our intermediate data structure we generated, and we go back and we mmap this file. And when you mmap a file, you basically get the memory for free. Because the moment you access that memory, the view of the file, that's when the kernel starts loading it. And when it doesn't need it anymore, you don't access it anymore, the kernel can throw it away because it's already on the disk. So mmapping was a key trick that we could use to do that. And another aspect of mmapping those data structures in the code is that you can share the memory between multiple processes. So again, if you have your button that is used by 2, 3, 4 processes, the code that is generated as a result of compiling this button can be shared. The memory that is necessary can be shared between those processes, which is great because that's less memory usage overall. And if you really want low on memory, and you have that kind of background application that you don't need anymore, well, all the information that you really need is already on disk in a cache file. So the memory, you can throw it away, because the moment you need it again, the moment that application comes into the foreground, well, just load it again off the disk. The kernel will do it for us. So we don't really have to do anything ourselves. You don't have to do anything manually. And like I said, the biggest problem is we do this again and again. Once you've done it once, the work of compiling something, then that's it. Next time you start the application, we can give practically a zero cost to the work of loading a QML file. There's a little bit of work to be done, I'll be honest. When you have connections between QML files, the one file uses the other, and there are references between those two, then some of those references can be only resolved at runtime. So there's still tiny little bit of work that we need to do. And there's the first question. Yay!
How's it going? What's the caching level of granularity? Are you caching at an application level, at a QML level, QML file, or especially relative to sharing it between applications? So
the granularity is first and foremost on a file level. I actually get back to how we store this on disk, the layout of this, but the granularity in principle is on a simply per file level. So every time we try to load a file, we will try to load the cache. And if the cache file is in a location that is accessible for multiple applications, then the applications will share that together. I'll go later. There's a slide that shows where those are located on disk, and then you'll see how this fits together.
What's the identification mechanism that this file is like this cache matches this file, especially when we load QML files from remote resources, how we would tell that this cache matches this file? What do you use for that?
So one thing I should note is that the caching mechanism does not, we don't do this for files that you load remotely. There's a bit of a caveat. So if you have remote imports from HTTP or somewhere, we don't do the caching, partly because of this. But for anything that's on disk, that in your regular development work cycle use, for that we have a mechanism of doing that. Actually, I'll get to that in a short while. But basically, we can detect when something changes, and we will recompile. But this goes a bit also into the file format of how we store things on disk. It's a binary format. And we encode various things in there. It's all little endian, because that's the only thing that matters, really. And for example, we include the Qt version in. So if you upgrade from one Qt version to another, the Qt version will be different of your pre-existing cache file, and we will regenerate this cache file. Because we rely on internal data structures that for the sake of performance, and so the cost of regenerating a cache file is relatively low. We think it's lower than the cost of trying to maintain different data structures. We also store the architecture, so if you put these things on, say, an NFS share, and you access it from 2 different machines with different architectures, in the unlikely event thereof at least, if you really do this, it should still work. It's not going to be blazing fast because it won't match, so it has to regenerate. But we store that at least, so it at least doesn't crash. And we also store a checksum of it. And this is where the regeneration comes in. We store a checksum of the dependencies, the things that we depend on. So brief summary, we regenerate it when the Qt version changes. So you upgrade to a Qt version, we'll regenerate the files. Should be fine, should be safe, and that avoids us crashes and extra work. And when any of the files that your QML file, your button, for example, uses, changes, that will cause a ripple effect in checksum changes, and we will regenerate the cache file as well. So hopefully that answers your question. It should be entirely transparent as a developer, in fact. The location where those files go, we have basically a simple strategy of 2. First, we try to store the cache file next to the QML file or the JS file. The same thing works also for JavaScript files. So for JavaScript imports, we do the same thing. So we store it right next to the QML file. But it might happen that we don't have write access to that directory. That's quite likely, or quite possible. And in that scenario, we'll end up going away from sharing, and we'll go into a directory that is private to the application. So like on a Linux system, we'll end up in a .cache directory in your home, and then there's the application name, and then there'll be a QML cache directory, and then there'll be a bunch of files, and they are the result of just concatenating the original source path into a SHA-1. So that gives a unique file name. So if you want to make sure that things are cached between multiple processes sharing the same components, you need to just make sure that the cache file can be created in that shared location instead of in the private location. This means if you put QML source code into a Qt resource, it is private to the application. And the cache file, as a consequence, will not be shared across applications. It will still work repeatedly because we can't write into the resource system itself, so we'll write it into this home directory there, into that unique location. But if you want to share something between applications, you should use the file system, basically. Yes, there's a question there.
Question. Why store the compiled QML and JS files next to the QML and JS files on the file system? Because on Mac and iOS, for example, the bundle location is not a place you should be writing to, even if you necessarily have write access like you might on Mac OS. Like I said, the motivation for writing next to it is because it's the most simple mechanism for a scenario where you want to share the cache files. On iOS, you don't want to share those cache files because you have a bundle, like you said, so it doesn't really matter where we store it. Therefore, we'll pick the cache location. So that won't be on iOS, of course, the home directory. It'll be, I don't know where, some private location to the application. But in a non-sharing scenario, you don't have that. But when you want to build a system with Qt from the ground up, and you want to
take these things into account and try to optimize it really for memory, then you are also usually in a situation of power where you control the file system and the permissions, and you can make sure that these things work.
Could I also, at least in theory, bundle my application already with the precompiled cached files and put them into the resource, or is that nothing I should do?
So currently those cache files are generated on the fly the first time, but that is an intermediate. That is just the current state of affairs. So I don't want to stop there. I want to go further, that you can generate these things ahead of time. I'll elaborate a bit on that later, but the idea is that in the near future, I want to make it possible for you to not have to ship the QML source code at all anymore. That's basically the motivation. So actually, that's where my slides led me to. So what I want to have I don't know if hopefully 5.9, but this is sort of the next thing that the concept or the logical iteration after that is to go ahead and provide a tool that allows you to generate these cache files ahead of time, either bundle them in a resource uncompressed, that would be one option, or find some other mechanism of deploying them, as long as we can basically mmap them. So as a resource, if it's not compressed, we can get a reference to it, and that would give us that kind of access. Otherwise, we need a deployment mechanism. But the intent is to consciously introduce a compilation step in the development workflow. So where currently you just write your QML files, you start your application, and it does these things behind the scenes, I do very much intend to introduce a conscious step of compilation in the development of a QML application, so that you press a build Control B or whatever you use, for example, in Creator, and it will compile. It will explicitly compile the QML files and create those cache files then. Because once we introduce that, then we can build on that, and we can add more functionality. We can more stricter type checking. But this is a bit of a tricky problem actually to implement, and this is why we didn't just do it naturally, because you can have a very dynamic setup, and people sometimes do that in a QML application. When you say import Qt, that's usually a fairly static thing. Qt is always in one location. But if you have your own module or your own plugin, you can, at runtime, affect where the QML engine is going to find it by setting the import paths. You can programmatically do it on the Qt QML engine. You can change the list of directories we're going to look. You can change it at runtime. You can change it via environment variable before startup. And that affects how that can affect everything, actually. That can affect whether you get a bluely themed button or a gray themed button, right? In two different locations. So because of this flexibility, it's difficult to also do this at the development time. And we're not 100% sure yet how to do it, but my gut's feeling is, and this is where, like, you tell me, would this be okay or not? Or where you say, yep, this should be fine. The idea would be to say, okay, I have a QML application with lots of little components, and I'm going to start to specify my import paths at build time as well, at development time. And we'll use those. We already have a list of those anyway. We know, like, you use Qt Multimedia, okay, so then we'll include the import paths for Qt Multimedia. And if you start using it, that's fine. But anything we will then compile at application development time will not be subject to changes of the import paths. Does that still make sense? So we will look up all your dependencies at compile time. We'll use them. We'll use what we can find, and we'll record that as well. And then when at runtime you start loading that component, we will completely ignore what you've set as the import paths. There's a doubtful look there.
No, I'm not sure if you were waiting for me or not. It seems like besides the paths, you'd also have issues with translations. How are QSTR, how's that handled?
So translations should be not affected by this, because your translations are not stored in the source code anyway.
right? Your translations are a parallel data structure that you have, right? You have you have your QML source code with QSTR calls, for example, and you can run L update on it to extract all of the strings that need to be translated, and then you'll translate them separately, and you do L release to generate the Qt message files, right? And those you deploy separately anyway. And you can still load those dynamically. So that is not the translation mechanism in Qt is basically a runtime mechanism and will always be. So you don't have to choose the language when you develop the version. It's an interesting optimization, though. You could theory say, okay, I know I'm going to ship this build only in Spanish, so I might as well replace all the QSTRs with the Spanish strings right away. This could do, actually. Maybe I should consider doing that. But those are scenarios that you end up with when these things become explicit. And you could start doing these optimizations then as well. For example, for translations.
Question. Caching is cool. I wonder how this work lines up with QML compiler.
So the connection between the QML compiler and this caching is that at the moment they are, this is a great question actually, they're in parallel basically. Or no, actually they're orthogonal. Sorry, they're orthogonal. So the Qt compiler takes your QML source code, one file at a time, and it will generate C++ code. And that C++ code will be compiled to object code and then to object files in native code and linked into your application. And the meta information about what it takes to, what other things we need to do to instantiate your button, that information is just stored as is separately on the side. And the end result is roughly the same as the cache files. But it's not quite the truth, because currently the Qt compiler has less visibility into the dependencies than the caching that the QML engine has at runtime. So since those cache files are currently generated at runtime, we have perfect visibility. If you access the width property of another Qt item, we know this is property number 23. And so we can generate code that says, look up property number 23, because we have already found that dependency. But in the current setup of the Qt compiler, because of this dynamic import path situation, we don't know that. So the only thing the Qt compiler can generate as code is to say, well, give me the width property. It's called width, and here's the string. So it can't say this is property number 23. So that means that currently the Qt compiler's code will be, at least when it comes to things like property access or generally accessing dependencies, will be slightly slower. So the cache files are more efficient. But once we have settled on a scheme of resolving type dependencies at application development time, then we can bring that visibility also to the Qt compiler. And conceptually, I expect them to merge, basically. You can think also of one more advantage when you generate C++ code. You do end up with code that becomes visible when you use link time code generation or link time optimization. Because you have object files that when you use link time optimizations will not contain native code, but they will contain whatever IR your compiler has. And so whole program optimizations could really, really take a step further. So case in point, if you access the width property of a Qt item, we could generate code that really static casts to a Qt item and calls width. And with whole program optimization, the compiler can really, or the linker then can really inline this width call. This is something that we can't do with the caching architecture. So that's why I personally see always both a bit coexisting. Running a little low on time, I think. The one other thing we've that's sort of hot on the heels going on right now, but we really need to tackle a bit more soon is memory consumption in the QML engine is still a bit of something we're not quite happy with. So we're currently playing with making this better. So this is something I expect in the near future as well.
Okay, one last question.
Is there a two-way QML converter, like parser, to where if you have an object running and you modify it, and then you want to get the QML that made that up after you modified it, is there a two-way parsing QML tool?
So let's see if I understand this correctly. Do you mean that you have
QML component, you load it, you change some aspects of it, some values or properties, and then you want to generate code, QML source code out of it again. That functionality doesn't really exist at this point. It's probably not too difficult to do once you decide what information you do want to persist and what you don't want to persist. So it's not entirely obvious, but in principle you could do something like this at least. You could start small by just doing this only on constants and basically calculate the difference for constant binding initializations, like the width. So it initially starts with 100 pixels. You change it to 200 pixels at runtime. You serialize it. Say, okay, I'm going to serialize everything that is constant, which means the written out width will be more. But this is interesting. It's the first time I hear of this idea, actually. It's the first time I hear somebody ask this idea. So I don't know the use case yet, but maybe you can tell me afterwards. Be curious.
Okay, that's all. Oh, sorry, that's all the time that we have. Thanks very much for your attention. Thank you, Simon.
Thank you.